So again, going through all that, an important day today. Make sure we're locked into what's going on. A particle moves along the x-axis. Its initial position at t equals 0 is 15. The figure shows velocity. Okay. I didn't do a great job on labels here, but we're assuming that all of these are from t equals 0 to t equals c. So all of them are on the full interval. What is the displacement? Show me with your fingers, what is the displacement on this graph going to be? It is 3. Aiden H, what'd you do to find displacement? 8, 21, and 10. He integrated from 0 to c v of t dt. That is how we find displacement. You just find the integration. And for us, in this problem, it is saying 8 minus 21 because it's below the x-axis, and plus 10. That's where I'm getting negative 3 from. There's my first one. Second one. What is the total distance traveled? Yeah, that one's a little bit tougher to show me with your hands. Maddie, what'd you do here? Absolute value of velocity. We're integrating velocity, but the absolute value of it. And so when she takes these numbers, she's got these same values. The only difference is I don't care that they're negative. They're all going to be positive because I'm doing the absolute value. That is why I'm getting 39 in the end. What is the ending position? Show me your fingers. What do you find for ending position? Ending position is going to be 12. Austin, how'd you get 12? Okay, cool. We have a starting position. It's 15. We are adding to that the integration from 0 to c v of t dt. That's what we did over here or up here. That's the change. Start plus change equals end. And so he is taking 15 minus 3. That is why his final answer is 12. Questions there? An important question. Not what we're doing today, but an important question to make sure we've got that locked in for the week. Again, today, the thing I'm teaching you today, it's on next Thursday's test. It's going to look very similar to this. I guarantee the thing we're learning today is going to be on the AP exam in May. It's going to be a free response question. It's going to be worth 9 points. You got to score 40 points to pass. By the time we get done with this chapter, this will be our third free response question that we've seen. Okay, that 27 points on the AP exam. So just this chapter alone can get you 27, and I'm not counting any multiple choice. Okay, so a very, very important chapter, especially today. Okay, fish. And this is a question. When I'm trying to scare a student, when I'm like, ooh, calculus is hard, this is the type of question I would pull up on my board. Okay, I would look at it and be like, ooh, look at this big old crazy story problem with some fancy stuff in it. It's not as bad as it seems. The key to being successful here is to break it down and label stuff. If you label it, you'll have success. If you just try to jump at it, it'll beat you up. Okay, so label stuff as we go. Fish enter a lake at a rate modeled by this equation right here. Fish leave the lake at a rate modeled by that equation, L of t. Both E of t and L of t are measured in fish per hour, and t is measured in hours since midnight. Okay, so the first thing I would always suggest you doing is reading it, and then you read it again and start taking out the information. Okay, so fish enter the lake. We get E of t first. What does E of t represent in this problem? The rate they enter is a great description. Tell me if it's an amount or a rate. It is a rate. Okay, the rate that what enters? The rate fish in. It is the fish in rate. The rate of fish entering the lake. Okay, it's important because this is often I call these rate in, rate out questions. That's my rate in. We got L of t. What is L of t telling me? The rate of fish out. If you can draw a picture, that's helpful. So here is my lake. I've got R of t, which is fish in rate. Then I have L of t. L of t is a fish out rate. And labeling it rate is the most important word up there. Okay. Oh, my fault. I was thinking about the last problem. Sorry. E of t. Fish in, fish out rates. Very important to understand. Anything else we need to pull from up there? I think that's the major stuff since midnight, but that's the setup. Everybody good with what we've labeled? Part A says how many fish enter the lake over the 5-hour period from 0 to midnight. Give your answer to the nearest whole number. Often we round it. Here they do say round it, so we're going to round it. How can I find the amount of fish given what we're given? We integrate, right? We've got a rate. We want to know an amount. How do we go from rate to an amount? We integrate. We integrate from 0 to 5. What thing are we going to integrate if we want to know the amount of fish that enter? E of t. We integrate the fish in rate, E of t dt. Boom. Type that into your calculator. Go ahead and do that. Here we go. So the first thing that I'm doing on my paper or on my calculator is I'm typing these in as y1 and y2. Okay. E of t is y1. L of t is y2. It's just going to save me time later on. Okay. Make sure I'm in radians. I am. So again, we just decided that to find my answer, we are going to integrate. So math 9, we are integrating from 0 until 9 or 0 till 5. And I want to integrate the rate in. So I'm going to go y1 dt, hit enter. Boom, there's my answer. What is the actual answer that I need here? 153, because it did say round it to the nearest whole number. So maybe not equal signs, but approximately 153 fish. I integrated the rate that tells me an amount. Questions on A. That's 2 points on the AP exam. Here's the breakdown. That scored me 2 points just now. 1 point, I have to write the integral. I can't just write the answer. And then 1 point for the answer, 153. 1 point for the integral, 1 point for the answer. That's 2 out of the necessary 40 points. Not too bad. What is the average number of fish that leave the lake over the 5-hour period from midnight to 5 a.m.? So I want to know the average number of fish that leave per hour. The average fish per hour that leave. So obviously, which equation am I dealing with? E of t or L of t? L of t, because I want to talk about them leaving. So it's L of t. I want to know the average rate they leave. L of t is the rate that they leave. I want to know the average rate. What do I do with something if I want to find the average of what is given? Average value. We integrate from 0 to 5. That will tell me the amount of fish. But if I want to know the average rate, then I'm going to throw that 1/5 out in front. That is finding the average value. Since they told me the rate which they leave, to find the average rate that they leave, I have to integrate with the 1/5 in front. Yes, sir. No, it does not say round here, so we are not rounding here. Okay, so in my calculator, I like to use the fraction button. So I went alpha F1, 1/5. I'm integrating math 9 from 0 to 5. Which equation am I plugging in inside the parentheses here? Y2, because I saved my L of t as Y2. dt, hit enter. 6.059 is my answer here. That right there, that is fish per hour, because that's what it told. I started with fish per hour, and I found the average value of it, so it's going to still be fish per hour. Questions on B. Letter C is the big one. Okay, on this last one, again, we scored 1 point for writing this down. You've got to write that down. 1 point for that. We're up to 4 points. Luke. That's fine. I would always just write L of t because it's going to save me time, and I'm going to use it in my calculator anyways, but you could write the equation as well. Letter C. At what time is the greatest number of fish in the lake? Greatest number of fish. What's another phrase for the greatest number of fish? That is the max value. The absolute maximum amount. I can't spell value. At max value, the absolute maximum value. That's the same question. Okay? We want to justify an absolute maximum value. How do we justify an absolute maximum value? This is a table question, okay? This is the big one. Anytime we do a rate in, rate out question, the table questions are going to be worth by far the most amount of points. So you want to make sure you set them up. We're going to have a time, and we're going to have a number of fish, okay? And we got to figure out how to calculate that here in a second. Where could I have an absolute maximum? Endpoints, critical points. So 0 and 5, there's two of my values. Oh, my bad, 0 and 8. 0 and 8, because I'm going from 0 to 8 now. 0 to 8. I need to know critical values. Think about what critical values are. Critical values are when the derivative, or for this problem, where the rate is 0. Where the rate is 0. The rate of fish in the lake. How can I figure out the rate of fish that are actually in the lake? Talk with your neighbor for a second. Come up with an answer. We know the rate of fish that enter. We know the rate of fish that leave. How do I know the rate of fish that are actually there? What can I do? E of t, that is the rate in, minus the rate out. Rate in minus rate out is going to tell me the rate of fish that are in the lake. We could just write E of t minus L of t. I always like giving it a letter just that way I can understand it. What letter do you want to give it? R of t, sure. The rate of fish. We called it R of t last period. We called it F of t. Doesn't matter. I just like to label it. It helps me out in the future. You don't have to, though. If you just want to say E of t minus L of t, go for it. Okay? That is the rate. What do I do with a rate to find critical points? We set it equal to 0. You score a point on this question if you write E of t minus L of t equals 0. You need to write that down on this problem. So E of t minus L of t is equal to 0. That's going to score me a point. I want to know when that's equal to 0. So in my calculator here, there's lots of different ways of doing it. My last class, one student wanted to graph E of t, graph L of t, and see where they cross. That's when they would be equal to 0. That works. I would rather do what we just said. Okay, so what I'm going to do here, I'm going to make a y3, and I'm going to go E of t, y1, minus L of t, y2. The reason I do that is because I know where it's what I want. I want to know when it's 0. Now I don't have to go look to see where they intersect. I'm just going to zeros and finding those values. If I graph all of this, then it gets a little crazy. So the other thing I like to do is then go over the equal sign. So look at my cursor. See how it's over the equal sign? Right now it's bold. If I hit enter on it, it goes not bold. And if it's not bold, it's not going to graph when I go to the graphing part. So I'm going to turn it off there as well. Okay, so just turn it off. The only thing that's going to graph when I hit graph now is y1 minus y2. Everybody good there? All right, I'm going to go zoom 6 just to give myself a standard zoom. I'm doing too many things on my computer, so my computer's going really slow today. Oh my goodness. All right, well, I shouldn't have been doing so much things. That's all right. It'll graph eventually. Cool. There's my graph. I want to know when I'm equal to 0, and I want to be on the interval from 0 to 8. So if you want to, you could change your window and make your window from 0 to 8. So if you want here, you could go x min 0, x max 8, just to zoom it in a little bit. Hit graph again. So we type that in. I want to find when it is 0. So then again, I'm going to go second, calculate. Which thing do I want to calculate? The 0. I'm going to go to number 2 to 0. Left bound, right now it says 4. So here's 4. It's right here. That's not wrong, but I can move my cursor if I want to see it. There it is. All right, we finally see it. It's on the left side. I'm going to hit enter. Now I'm going to move it to the right side of that spot. Hit enter again. Hit enter a third time. My answer is 6.203. I'm going to write that down. So when is E of t minus L of t equals 0? When t equals 6.203. Oh, did I round wrong? 4, sorry. That's my critical point. So I'm going to put that on my table as well. Now, what I don't want to do is I really don't want to round that number. In the middle of a calculus problem, you don't want to round. Okay, so I need to save this number. And I've shown you this before, but let me remind you. So what I'm going to do next is I'm going to hit second quit and go back to my normal screen. Since the last thing I found was that 6.204 number, if I hit X, I just hit the X button and I'm going to hit enter. There is that number that I was just talking about. It's all written out there for me, 6.203. I want to save that as the letter A. So watch. So what I'm going to do is I'm going to hit that X button right there. And I'm going to store it. S-T-O. Okay, this button right here. Store. The one that's red highlighted. Store. And I'm going to store it as alpha A. So what that will do for me now is anytime I just type in the letter A, it's going to give me that number unrounded. Okay, and that's what I need here as I do this free response question. Everybody go with me to this point? All right. So I've got that saved. These are the times I want to know the greatest number of fish. Bless you. What do I need to do in my calculator to find the number of fish in the lake? This right here is the rate of fish in the lake. I want to know the amount of fish in the lake. What am I going to do with that thing to find the amount? I'm going to integrate from 0 until whatever my time is. So I'm integrating from 0 to t, because for each one, the time is different. On this one, I'm going to integrate to 0. This one different. Of r of t dt. That is going to tell me the amount of fish in my lake. What am I going to get if I integrate starting at 0 and go till 0? 0. So it's not at 0. That's not the max amount of fish. There weren't any fish in the lake. Then I want to integrate to 6.204. So in my calculator, I'm going math 9. I'm integrating from 0 until when? Alpha A, because I've saved that number. I could have just picked it right there, but alpha A. I'm going to integrate which equation here? Y3, because I already typed that thing in as Y3. So I'm going alpha F4. I'm going to go down to Y3. And then I'm going to go dx. I typed that whole thing in. I hit enter. 135.015. That's how many fish are in my lake at 6 hours. Now I'm going to do the same thing at 8 because I want to know when it's the greatest. So I'm going to do the same thing. Go math 9. This time I'm integrating from 0 until 8. Alpha F4, Y3, dx, hit enter. At 8, I've got 80.920. The question is, at what time is the greatest number of fish in the lake? What is the answer to my question? This guy right here, 6.204. At t equals 6.204, fish are max. That is my answer. That question right there on the AP exam is worth 3 points. Okay? Just look to see how they scored this on the AP exam. You got 1 point if you compared E of t minus L of t. So we got 1 point for writing E of t minus L of t equals 0. We got 1 point for getting our answer and 1 point for our justification, which was our table. Everybody with me to that point? Last one. Is the rate of change in the number of fish in the lake increasing or decreasing at 5? Is the rate of change of the number of fish increasing or decreasing? They're telling you a rate. They're asking you, is the rate increasing or decreasing? Talk with your neighbor. Come up with a concept. As I'm listening, I'm hearing a lot of graph, which is okay. I'm fine with that. What am I going to look for to know if the rate is increasing or decreasing? If I gave you an equation, I said, when is this increasing or decreasing? What would you do with it? You would find the derivative. You want to know if the rate is increasing or decreasing, the rate of fish. Well, we have that. R of t is what we found a second ago, right? We had E of t minus L of t. I'm just rewriting it. You don't have to rewrite that there. But that's our rate of fish. If I want to know if that's increasing or decreasing, what do I need to do with that thing? Do what? Find the derivative. Well, the good news is it's just R prime of t, and it would be E prime of t minus L prime of t. If I want to know if it's increasing or decreasing at 5, what do I need to do? Yeah, I'm finding a derivative here, so I just plug it in. Find R prime at 5. I can do that really easily. A lot of you said look at the graph. I don't even have to look at the graph. How do I find a derivative in my calculator? Math 8, numerical derivative, math 8. I'm going to go dx. I'm going to type in my equation. Which equation do I want to type in there? Y3, because Y3 was E of t minus L of t. I'm just going to go Y3. And x is equal to 5. Hit enter. Negative 10.723. So what do we think? Is the rate increasing or decreasing at t equals 5? Decreasing. Why? Decreasing because R prime of 5 is negative. That's it. That's all you need to write there. Really, I wrote a lot of work down there. But as long as I called it R prime earlier, I really don't even need that. I just need these last two things. I found the derivative. Okay. I compared E prime and L prime at 5. Okay. Looking at our answer key, here's what they did. They didn't give it a cool name. They just called it E prime minus L prime. It was negative 10, and that number is less than 0. So as long as you consider E prime at 5 and L prime at 5, you scored a point. And then your answer with an explanation. It is decreasing. Why? Because that rate is less than 0. The derivative is less than 0. Makes sense on how we scored that. That's 9 points. It's overwhelming if you look at that and say, I have to score all 9 points. What's a good score on a free response AP question? 6 is excellent. If you're getting 3, you're doing pretty well. Okay, as you look at this problem, can you guarantee me those first 4 points? Those are pretty easy. Those first 4, no doubt. That last one, or part C, a little bit challenging. And part D, you got to know what you're doing, but once you know it, it's not too bad. That's where we got to get to. We got to get to the place on these free response questions where you're getting 6s. If you're getting 6s, you're getting a 5 on this AP exam. Go to the backside. Stay with me. I got to go fast because I take too long on the front side. People enter a line at an escalator modeled by R of t, where R of t is measured in people per second and t is measured in seconds. As people get on the escalator, they leave the line at a constant rate, bless you, of 0.7 people per second. This part right here really frustrates people. We'll get to it. There are 20 people in line at t equals 0. Okay? So again, drawing a little picture is helpful here, especially for these questions. So here's my escalator. The whole part is about the line. Okay? We've got a line of people trying to get on the escalator. The first thing we've got is R of t. What can I label R of t as? That's the rate in. Yeah, the entering value. That's my rate, and make sure it's a rate. R of t. That is my rate in line. That's the people getting in line. The other thing they gave me was this 0.7. What is that 0.7 going to be? That is the rate out. That is the people leaving the line to get on the escalator. It's just 0.7. A lot of people want to make it like 0.7t. 0.7t is the integral. You're finding the antiderivative of 0.7. If you write 0.7t, that'll tell you the amount of people. But 0.7 is a constant rate. Every second, 0.7 people leave the escalator. So someone's arm gets stuck, but the rest of them get off. Okay? 0.7 every second. Okay, that's the rate out. And then I've got this 20 right here. What is that 20 going to be? That's our start. That's how many start with 20 people. Okay, make sure we label that. That's something they try to sneak in there and see if you forget it. Okay, if you add it to your picture, you won't forget it. Everybody good with my picture and what I labeled? Try A and B without me. Go. how many people enter the line? How many people enter the line for the escalator during the time interval from 0 to 300? Okay. How many people enter the line? What am I going to do with this? Which equation am I using? Am I using R of t or the 0.7? R of t, because it's the amount of people entering the line. So we're going to deal with R of t. What do I need to do with that rate to tell me how many people? Integrate it from when to when? 0 to 300. dt. Do I need the 20 on this one? No, because this is just asking how many people enter. Not how many people are in line. It's how many people enter the line. Okay, so again, here's what I did. I went to window. No, I didn't go to window. I went to y equals. I typed in that equation. Okay, that's just my normal equation that I typed in. Second quit. We go math 9. We integrate that thing from 0 to 300. And then right here we go alpha f4 y1 dx. We type it in. We hit enter. And the answer is 270. Okay, that is the amount. That's not approximately. It is an answer. It's 270 people. That is how many people enter the line during that time period. Everybody go with me on the first one. That's 2 points. One for writing the integral, one for giving an answer. Second one says, during the time interval from 0 to 300, there are always people in line. How many people are in line at t equals 300? I want to know how many people are still in line at t equals 300. Everybody got a thought on what we need to do here? Start plus change equals end. Our best friend. Start plus change equals end. How much should I start with? 20. Plus the change here. Yeah, so we can do some different things. Luke, you're doing just some good old algebra skills, and that works perfectly well here. Let's write it out in calculus. Okay, so I'm going to integrate the change in what's happening. Okay, so 270 is great, but let's write it down. So from 0 to 300. If I want to know the amount of people in the line, rate in minus rate out. Okay, so my rate in is R of t minus my rate out. What's my rate out going to be? Just 0.7. So again, what Luke's saying here is perfectly good. Here's how they did it. There's two different ways you could do it. Okay, here's the way I'm going to show you. Okay, because otherwise you start getting confused about that 0.7. Here's what we're doing. We're going to integrate from 0 to 300, the rate in minus the rate out. Don't put the t with it, dt. Okay? If your brain is thinking of it a little bit deeper, you're thinking, all right, rate in, or the start, plus the rate in change, that's that 270 here, minus the rate out. It's a constant of 0.7 times 300. Both of them get the same answer. Okay? They do the same thing. I'm going to tell you to do it this way because it applies more often, but the other way works as well. Does it make sense what I'm saying there? You're doing the same thing either way, but I'm going R of t minus 0.7 dt. Type that into my calculator. I'm going to hit enter. I should have gotten 80. Everybody good through part B? Part C. I got 60. It's 60 plus the 20. Plus the 20. Don't forget your starting amount. Okay, just again, so you can see the scoring on this. 1 point if you included the rate out, and 1 point for your answer. Okay. T is, for when t is greater than 300. So look at this. This is confusing to some. For all, really. When t is greater than 300, what it says up here is nobody else enters the line. So after 300 seconds, nobody's entering the line anymore. That line stops growing. Okay, it's just people leaving. Okay, that's what it's saying. So when people are just leaving at the end, what is the first time when there are no people in line for the escalator? So what do I need to do if I want to know when there's nobody left in line? How many people are in line after at t is greater than 300? 80. That's what we found right here, where you're taking whatever this answer is. Even if you would have gotten this answer wrong, you can still get full credit here as long as you take that answer to there. So whatever we started with, which would have been 80, and then what do I need to know for when is the first time when there are no people left? Divide by 0.7. Let's write an equation, though. So 80 minus 0.7t. Technically, this is the integral of that. I took the antiderivative. 0.7, I add 1 to my exponent, it's 0.7t. That's telling me the amount of people. So I have 80 people, and every second, I'm losing another person. I'm losing 0.7 of a person. What do I want to be true about this equation? I want it to be 0. Okay? If I want there to be nobody left in line, write out that equation. That's scoring you points. Okay? Writing down what you're thinking. Okay? So 80 equals 0.7t. Then what do? Divide by 0.7. T equals 114.286. That's not the right answer. Why do I got to add 300, Luke? Yeah, this is starting when t is greater than 300. Okay, so there weren't anyone in line before, or there was lots of people in line before this. We add 300 to that. My real answer is 414.286. Round to 3 decimals there. Your scoring on that one was really just the answer, 414.286. So far we've scored 5 points. This last one is the big one. From 0 to 300, at what time are the people in line a minimum? To the nearest whole number, find the number of people in line at that time. I want to know when something is a minimum, and I'm trying to justify my answer. The amount of people is a minimum. What do I do to justify the amount of people being a minimum? This is a table question. I need a T. When can minimums happen? End points, 0 to 300, and critical points. Critical points are when, think about it, critical points are when the derivative is 0, or in other words, when the rate is 0. The rate is 0. So what is going to tell me a rate? What is the rate of people in line? It's going to be what? R of t minus 0.7 is what I'm looking for. Okay? And what do I want to be true about R of t minus 0.7? Equals 0. That scores me a point. Writing R of t, the rate in, minus the rate out, equal to 0. That is going to find me my critical points, because that's when the rate is 0. Okay? So we've got to figure that out. So I can go to y equals. Okay? I'm going to go ahead. I got that equation. For R2, I'm just going to do 0.7. So for Y3, I'm going to type in Y1 minus Y2. Okay, and I'm only going to graph that one. So again, I turned off those other ones. If I just hit graph now, it's not going to show it to me. I need to change my window from 0 until when do I need to change my window? 300, because I want to know during that whole time. If I graph it, some craziness going on. But there is my graph. How many critical numbers do I have here? 2, because there's 2 places when it's equal to 0. So I'm going to go second. Calculate the zeros. Which one of these is going to be a minimum? Is it the first one that's going to be a minimum or the second one? The first one. It's only going to be the first one because the second one, it's going from positive to negative. But that first one, since the derivative is changing from negative to positive, that makes this thing a minimum. So this is the one that I really care about more than anything else. I go to the left, I hit enter. I go to the right, I hit enter again. I hit enter a third time. I want to write down that value, 33.013. That is one of the values that I'm checking. Okay? If you look at this, at the answer key here, you have to identify that one. So I always tell you to identify both of them, but you technically need to identify that first one. Okay? We would keep plugging in. I ran out of time, but there's my answer. All right, finishing this problem here after the bell rang. Sorry about that. So we found this. The key to find the people in line for the escalator, we are using this equation right here. Okay, so we're taking the 20 plus the R of t minus D of t. So that's basically the same thing we did in part B. We're plugging in 20. We're plugging in that value that we found, this 33.013. And then we plugged in T2, which would have been the other ordered pair right here. That's the other time when t was equal to 0. Those were the values I was looking for. I want to know when it was at a minimum. So it was a minimum at 33.013 seconds. What is the minimum? It is 4 people, because that is what this rounds to the nearest value. Hope that makes sense.